All right, 19.2, properties of reflection. So I can reflect a figure and then also use an algebraic expression to represent the reflection. So a reflection is a transformation of a figure that flips the figure across a line. Okay, it can be any line, but it has to be a line. It's almost like when you fold a piece of paper, right? That's our line. So whatever's on the left, you know, depending on how you fold it, I guess, will then be right perfectly on top of whatever's on the right. Okay, and then you can fold it up and down the same too. You can find it diagonally, but it's when you fold a piece of paper, that line that you folded on is what we would call our line of reflection. So that's the second key term, is that a line, it's the line that a figure is flipped across to create a mirror image of an original figure. So a reflection is like a mirror, right? That's why it's called that. And so everything is opposite. So think about when you try to fix something in your, in your hair in a mirror, it's kind of hard because you're trying to do, it's in the front, you're trying to grab the back, right? So it's a complete flip of everything. Okay. So we're still talking about transformations. This is still a type of transformation. And then we're still talking about pre-images and images, okay? We're just talking about a different kind. So a figure shows triangle XYZ. We're going to graph the image, remember that's the second one, of the triangle after reflecting it across the x-axis. So this is my x-axis right here, okay? And when we reflect it over the x-axis, it's like we're folding it right there. So you'll see these nice arrows show us that they should be the same distance away from that line, right? That's the other thing, is if I'm folding it on that line, if it's 5 underneath, when I reflect it and fold right here, it should be 5 above. So you can see it's perfectly 5 and 5. So let's just start writing our points down, because we're going to have to write an algebraic expression. So like z is at -5. 1, 2, 3, 4, 5, 6. So you'll see z prime is at 5. Oh, I have these totally flipped. Okay, hold on. Sorry, I put my y's and my x's. So 6, -5. 6, -5. All right, 1, 2, 3, 4, 5, 6, yeah. And then you'll see that 6, 5. There we go. So see, 1, 2, 3, 4, 5. So then let's do x. So x is at 1, -3. And then x prime is still at 1, but now it's at 1, 2, 3. It's at +3. And then our last one, y, is at 1, 2, 3, 4, -1, and y prime, it's right here, is at 4, 1. So then we can reconnect them. And so you'll see it's the same triangle. Oops, sorry, I was trying to fix this line. I didn't connect it very well. It's the same exact triangle, but flipped. So see, everything's now opposite. It's also like when you do those ink blots, right? You paint one side and then you fold it in half. The other side is matching, right? It's like butterfly wings. So for our algebraic expression, what we want to do is what happened from x to y to change. So if we look at all of our x's, did they change at all? Did we do anything to them? No. So we're just going to say x. But what happened to my y's? They all started at negative, and now they are all positive. So we would call them opposites of each other. -5 is an opposite of 5. -3 is the opposite of 3, and -1, opposite of it, is 1. The way we represent opposites in math is actually negative. So we're going to write -y. And this does not mean negative, this means opposite. Okay, it means opposite, not negative. So you'll notice, just a case in point, if this is -5, it went to 5, it went to the opposite. It didn't stay -5. It's saying if this is y, right? If it's -5, I want to take the opposite of it, and that's how I get 5. All right, the figure shows trapezoid ABCD. Graph the image of the trapezoid after reflection across the x-axis. Label the vertices of the image. That means just make sure it says A, B, C, D prime. All right, so here's our x-axis. How do trapezoid ABCD and trapezoid ABCD prime compare? And then suppose your reflection across ABCD across the y-axis. How would the orientation of the image of the trapezoid compare with the orientation of the pre-image? Okay, so let's do the first part. Let's just reflect it over the x-axis. The nice thing is, when we reflect over the x-axis, this is actually the rule from up here. This is the exact same rule every time, so I'll show you. It needs to be to the same distance, right? So D is 1 up, so D is going to be 1 down. Here's D prime. C is 1 up, so I'm going to come 1 down. C prime. A is 1, 2, 3, 4. Oh, 1, 2, 3, 4 up, so I'm going to go 1, 2, 3, 4 down. And then B is also 1, 2, 3, 4 up, so 1, 2, 3, 4 down. So see, everything is flipped. Now, if we listed our points, we would see that all of our x's, all of our y's did actually just switch. Okay, so look, A is at 1, 2, 3, -3, 1, 2, 3, 4. And A prime is still a -3, it's just now a -4. See, look, it just went to its opposite. B is at 1, 4, and B prime is at 1, -4. So see, it's just opposite. So how do the trapezoids, these two trapezoids, compare? We would say that they're actually congruent. Everything about them is the same. Everything. Their side lengths are the same. Their area is the same. Their perimeter is the same. We would say that they're actually congruent. Okay? They're completely congruent with each other. Okay, so let's look at x-axis or y-axis flip. So y-axis is here. Did not do a good job drawing that. Here. So just like with an x-axis, the y-axis, when I flip it over the y-axis, it needs to be the same distance on either side. So B is on the right-hand side. It now needs to move the left-hand side with the same distance, 1 and 1. A is on the left, so now I need to flip it to the right. 1, 2, 3, 1, 2, 3. Same with C and D, they need to flip. So 1, 2, 3, 1, 2, 3. Oh, look at this. C and D end up on top of each other, or primes. 1, 2, 3, 1, 2, 3. So C prime is now where D was, and T prime is now where C was. So how would the orientation of the image, that's the orange one I just drew, compare with the orientation of the pre-image, that's the blue one that we drew? How is their orientation changed? Well, they're flipped right to left instead of up and down, right? It's a right / left flip, or a horizontal flip. That seems weird because y-axis is an up-down, right? It's a vertical line, but because we're folding it there, think about when you fold vertically on a vertical line, everything goes left to right, which is horizontal, okay? So if we fold across a y-axis, everything's going to flip left to right, and if we flip on an x-axis, everything flips up and down. Okay. Okay, so we're going to do a practice with another practice with the y-axis, so that we can also talk about the rule or the algebraic representation. So we're going to do y-axis flip. We kind of just practiced that. Okay. We're going to look at the algebraic expression for it. So remember, it has to be the same distance. So I'm going to actually write my points down too, just to start. So z's at 1, 2, 3, and then 1, 2, 3, 4, right? 3. So it's 3 away, right? If we count 1, 2, 3 away from y, so it needs to be 3 away on the other side. 1, 2, 3. So here's z prime, and it's now at -3, 3. Remember from the last one we just did, y-axis is going to cause it to go left to right. So d is at 1, 2, 3, 4, 5. And it's at 1, 2, 3, 4. So d prime, like I said, if it's 5 away, it's going to be 5 away. So 1, 2, 3, 4, 5. It's going to be way out here. D prime. -5, and then still at 4. See, 1, 2, 3, 4. Still lines up. Let's do m. 1, 2, 3, 0. So m prime. 1, 2, 3, 1, 2, 3. -3, 0. It's right here. It's a good check too. See, I did it okay because z and m still match, so they should. So that's a good check for me as well. And then p is at 1, 2, 3, 4, -1. And then p prime will be at 1, 2, 3, -4, -1. Hands in the way, there we go. And so you can see if I folded it, it would perfectly match. So then, what happened to my xy's to get my primes? Well, if we look, what changed? Maybe pause here, see if you can write the rule for y-axis reflection. What changed? Did the x's change or did the y's change? And how did they change? So, we would just say opposite of x, y. So you can see 4 went to -4, 3 went to -3, 5 went to -5, 3 went to -3. None of my y's changed. And that's tricky because for the y-axis, the y should change, but it's actually opposite. It's flipped like a reflection. If it's y-axis, it's actually the x's that change. They're flipped. Okay, so for this one, I want you to graph T, C, Z, F, and then you need to reflect it over the x-axis. What's really nice is you get to use the same rule as the x-axis, right? This is what happens. That doesn't ever change. It's the same rule every time. So it's really nice about reflections. This right here that I wrote down, this is the x-axis reflection rule. So we can always just use it. So pause, graph it, reflect it. Let's see if yours matches mine. Okay. So T, 1, 2, 1, 2. 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then 1, 2, 3, 4, 5. So there's my original shape. So then T prime should be at -2, 2. And C prime should be at -2, 5. And Z prime should be at -5, 4. And F prime should be at 5, 0, -5, 0. So you can see I can fold it, and they are the same distance apart. And this is still my rule. I just flip them. Right? I can even, I could write them down if I wanted to. I could have written them down before I even did it. And then just graphed these. So I'm not, you can see I'm not counting anymore. All I'm doing is I'm actually looking at the points here and flipping, making my y is opposite. I'm not even counting. And I'm not doing it by memory. This one's -5, so what are we going to do? Oh my goodness. So, my points down here are right. What did I just mess up? I'm not going to tell you. You have to tell me. And we'll talk about it in class. These points down below are right. These are right. My graph was not. You tell me when we get back to class. All right, things to remember. X-axis reflection, okay, equals xy to x opposite y. It's an up, down, flip. Y-axis reflection equals x, y goes to opposite x, y. It's a left, right, flip. All right, so your independent practice is a y-axis reflection because we only did one true example of that. So you are welcome to apply the rule that's up above. That's what I would do. I would just apply my rule and then go graph them and make sure I did it right. Notice on the mistake I made on the last example, after I wrote my points down, I knew something was wrong. The points is what made me realize it. So I would suggest writing your primes down and then graphing them. And then make sure, because it's an x-axis, that you did a right, left to right flip. Left to right, left to right flip, yeah. Alrighty. Until next time.